Okay guys, so from this lecture onwards we'll be seeing a new chapter which is liquid solution. So let's get started. Liquid solution. Okay, so first let us see what is a vapor pressure. So suppose we have a vessel kept at constant temperature. Okay, and we have some pure liquid, let's say XL, pure X liquid in the vessel, and this XL would have some molecules, gas molecules in the closed vessel, and these molecules would exert pressure P naught on the walls of this vessel. Okay, and how do we measure it? When we connect this vessel with another tube and we determine how much, and we have another liquid filled in this tube which is closed from the top. So let's say we had another liquid filled in this tube, and the difference in the height of the liquid filled in the U tube here would actually determine how much pressure P naught is exerted by the molecules or the gas molecules of pure XL present in this vessel. Okay, so these molecules will enter this U-shaped tube, and this difference in length of the liquid which has been raised here determines how much pressure that is being exerted on this surface of liquid here. Okay, so we can write X of L gets converted into X of G in the vessel, and delta H vaporization is positive. Okay, so rate of evaporation is constant, and just a note here that evaporation is a surface phenomena. Okay, next we can also say that rate of condensation increases with time. Rate of condensation increases with time, and rate of condensation actually depends upon the number of particles in the vapor phase per unit volume. So number of particles which are in the vapor phase per unit volume in this vessel determines the rate of condensation. So we are just writing that rate of condensation depends upon number of particles in vapor phase per unit volume. Okay, and we also know that solute plus solvent equals solution. Okay, and solute can be in any phase, that is solid, liquid or gas, when dissolved in, let's say, liquid solvent, becomes the basis of our chapter, which is liquid solution. Okay, so here we just define P naught in that vessel. So P naught here is nothing but the vapor pressure of pure liquid X. Okay, so we have already seen that rate of evaporation is constant. So as the rate of evaporation is constant in the above case, we can write that this is the rate of evaporation, and as the rate of evaporation is constant, more number of liquid particles in XL gets converted into Xg, and as the number of gaseous particles increases in the vessel, hence the rate of condensation would also increase. So this graph would have the rate of condensation, and when they meet at this point is said to be equilibrium point, at which rate of condensation is equals to rate of evaporation. So at this point rate of condensation is equals to rate of evaporation. So now let us define what is a vapor pressure. So vapor pressure is the pressure exerted by the vapor on its liquid surface at equilibrium. Okay, so we can write that pressure exerted by vapor on its liquid surface at equilibrium. This is important, that at equilibrium word is called vapor pressure of liquid. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing more on vapor pressure. So till then, good luck and goodbye.